Hey there, welcome to Pomodoro Joe for Tuesday, November 7th, 2023. Today we're looking at LeetCode problem 1921. Eliminate maximum number of monsters. This is a medium problem. Alright, so in this one we're playing a video game, and we're defending a city from a group of monsters. Now, these monsters are given to us as distances and speeds, so we know the distance the monster is to our city and the speed at which the monster moves. So that's distance and speed. Now, in our city, we have a weapon that once fully charged, we can eliminate one monster. However, the weapon takes 1 minute to charge, but the weapon starts fully charged. Alright, you lose when any monster reaches your city. If a monster reaches the city at the exact moment the weapon is fully charged, it counts as a loss. We need to return the maximum number of monsters we can eliminate before we lose, or n if we can eliminate all of the monsters. Alright, so this one should be pretty fun. We've got a bunch of monsters and they're attacking our city. Now these monsters start at different distances. That'll be in an array called dist. And each of these monsters has a different speed, and that's in this array called speed. So monster at index I will have distance at index I and speed at index I. Alright, now these monsters are all coming towards our city and we need to defend our city. So we have this weapon. It starts charged up, but we can only use it once per minute. It takes another minute to charge after we use it. And we can only eliminate one monster per charge. So we have an example here. So we have distance 1, 3, 4, and speed 1, 1, 1. Okay, so in our first round, we can eliminate the first monster, the one at 1. Then we can eliminate the second, and then we can eliminate the third, because it takes 1 minute between charges. So that's not too bad. We can eliminate all 3. All right, then in example 2, we have 4 monsters, distance 1, 1, 2, and 3, and then speed 1, 1, 1. All right, so we can eliminate the first monster in our first move. Then the second monster only has distance 1, and it moves at speed 1, so now it's reached our city, and we're done. We can only eliminate one monster. All right, so this looks pretty straightforward. Let's put 25 minutes on the Pomodoro timer, and we will get started. So just like a lot of the other problems we've done recently, we could go through and simulate this whole process of all the monsters coming toward our city and attacking it. Or we could go through and find a better way to do it. So let's use some math to find a better way. So the first thing I want to do is transform my monsters' speeds and distances into something that I can manage a little bit. I'd like to be able to sort these monsters by which monster is going to reach the city first, second, third, so the time until the monster reaches my city. Well, that's actually my clue right here. The time it's going to take the monster to reach my city. So if I went through every monster, I could use its speed and distance to calculate the time it's going to take for that monster to reach my city. So let's do that. Let's have some time to reach city. And this will just be an array. All right, then for every index in range, the length of my dist. All right, we're going to go through every monster and calculate the time it's going to take for that monster to reach this city. So I'll just call that t. And that's just going to be the distance the monster has to cover. So a distance at index I divided by the speed the monster can go. Speed at index I. Now I'm doing a floating point divide here, not an integer divide. All right, so let's see. This is the amount of time it's going to take for this monster to reach my city, so I'll add that to my list here. So now I've got a list of all the times it's going to take for all the monsters to reach my city. So now let's sort this time, because I'd like to eliminate the biggest threats first. So the monsters that are closest to my city or nearest in terms of time to reach my city, I'd like to eliminate those monsters first. So let's sort this. So that's just time to reach city dot sort. Okay, now I've sorted my monsters by how much time it's going to take to reach the city, and the smaller numbers, or the closer they are to my city time-wise, will come first, and then the other monsters, the ones that take the longest to reach my city, will be at the end of my list. So now I just go through my list, and I want to eliminate each monster in turn with my weapon as long as I can. So let's go through each monster in our list here. So this is monster. Let's start at index 0. So while we still have monsters, so while this monster is less than the length of our time to reach city, so while we still have monsters, so the monster is less than the length of our time to reach city, and we can eliminate this monster, then we will just advance to the next monster. So I'll just do this here, can eliminate monster. And we'll advance to the next monster. All right, now if we can't eliminate the monster, then we won't advance to the next monster. But in the end, we'll have the number of monsters we were able to eliminate right here, so we can return monster. Okay, so what's this can eliminate monster? So this can eliminate monster is just a placeholder for us figuring out whether or not we can actually get rid of this monster if we're able to charge our weapon before this monster reaches us. So our weapon can charge at a rate of once per minute. So as long as we have enough minutes before this monster reaches us to charge our weapon, then we can eliminate this monster. So how do we figure out if we have enough time to charge our weapon before this monster reaches us? Okay, so imagine this situation. In the very beginning, we'll use our weapon the very first time to take out the closest monster time-wise. Not necessarily the closest distance-wise, but the monster that will reach us the soonest. We take care of that monster. Now the weapon will take 1 minute to charge. So we use the weapon, it takes a minute to charge. Next we go on to the next index, the next monster, that's index 1. So the weapon took 1 minute to charge, and now we're on index 1 of our monster list. We take out that monster. Now our weapon takes 1 more minute to charge, so we're at 2 minutes. We're also at index 2 of our monster list, so on and so forth. So essentially, our index not only tells us the monster that we'll be taking out, it will also tell us the number of minutes we need for our weapon to recharge. So as long as we're able to recharge our weapon before the monster reaches our city, then we can take out that monster. So let's see. The time that we need will actually be represented by this monster index. Now, as long as that is less than the amount of time it actually takes this monster to reach us, so that's going to be time to reach city for this monster. If we took less time to charge our weapon, that's this index, then the time it's going to take for that monster to reach our city, then we can take that monster out before it reaches our city. So now, I think we have all of our pieces. We've gone through all of the monsters. We've calculated how much time it's going to take each monster to reach our city. We've sorted them in ascending order, and then we'll just go through and take out one monster at a time, checking whether or not we have enough time to recharge our weapon before the next monster in our list reaches us. At the very end, we just return the index, the number of monsters we were able to take out. Okay, let's run this and see how we do. All right, it works. Let's see if we can pass all the tests. And we pass. Let's see, we do okay. We beat 60% for runtime and 31% for memory, so that's not too bad. Now, let's see, we could go back. I'll do one little thing here. We'll do this max index, or what do I call this? So you can see we're calling length here and here. So we can just do that one time. So I just call it, what do I call this? Monster count. I'll just call it n. All right, in that case, I don't need this. Same thing here. Move this up here. No, I'll leave it where it is, never mind. All right, I think that's about it. Give this another shot. And we do a little bit better. So now we are at an 81% for runtime and a 10% for memory. So we took a little bit more memory, but we gained a lot in our runtime. So hey, that's not too bad. Now there are a couple other tricks we could use in here. We could actually use the map function to essentially go through our indices together, or go through our lists together and do our divides. We could also use the zip function to do the same thing. I don't know, I think this is pretty clean. I'm pretty happy with this. So I'm going to leave it at that, and I'm losing my voice. So I think that is it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.